The second theorem we want to look at in this chapter is called the mean value theorem. And it states that if you have a function that is continuous on a closed interval and differentiable on the open interval from a to b, and that's just like Rolle's theorem, but it does not have to be that f of a equals f of b. Those are the only two conditions for the mean value theorem, is that it has to be continuous on the closed interval and differentiable on the open. If those two things are true, then there has to be an x value, also called c, between a and b, where the first derivative at c is equal to f of b minus f of a all over b minus a. And I don't know if you realize it or not, but that's just the slope. That's y2 minus y1 over x2 minus x1, where your x's are the a and the b. Okay? So that's how we find average value, right? Remember when we were finding average rate of change? We did s of b minus s of a over b minus a. That's all it's saying. The mean value theorem says, and mean means average, that at some point, as long as those two conditions are met, the first derivative has to equal the average value, or the slope, between the two endpoints. If you think about it a little deeper, it just means that as long as those conditions are met, there has to be some point in that interval where the instantaneous rate of change, or the derivative, equals the average rate of change, which is the slope of the segment between the endpoints. For this example, we want to find the values of c guaranteed by the mean value theorem for the function f of x equals x plus 1 all over x on the interval from 1/2 to positive 2. So in order for us to apply the mean value theorem, what has to be true?
Rolle's theorem?
Rolle's theorem doesn't have to be completely true, but two of the three things that have to be true for Rolle's theorem. It has to be continuous and it has to be differentiable. So let's see if we believe it's continuous. Where's the only spot that function is going to be discontinuous? At 0, where the denominator is 0 there. Do y'all understand that? That's how you look for discontinuities? Okay. So it's only discontinuous at 0, and 0 is not in our interval. So we're okay with continuity from 1/2 to 2. Do we believe it's differentiable?
Yeah.
I couldn't say for sure until I looked at the derivative, but we're about to take it anyway. So we'll hold off on that. That's part of the mean value theorem anyways. I have to take the derivative and set it equal to the average value. So we'll hold off on that, but we'll go ahead and take the derivative. To take the derivative of that, we could do the quotient rule.
Yes.
We'll do the quotient rule. Or we could just split it up. And we could say x over x plus 1 over x, and we could say that's 1 plus 1 over x. It really doesn't matter. Which would you like to do? Quotient rule? All right, we'll do the quotient
Can we
rule.
bring the x up to the top and make it negative? And
Sure, that's the same as splitting it up. Yeah, you could do that. Do you guys want to do the quotient rule? No? Okay, we'll do it the other way. So if we bring the x up to the top, we have x to the negative 1, and we distribute it in. X to the negative 1 multiplied by x plus 1, and we can do that because it's a monomial. And we get x to the 0, which is just 1 plus 1x to the negative 1. And if we take the derivative of that, f prime of x, we get 0 minus 1 x to the negative 2. So we get negative 1 over x squared. So there's my derivative. That's what I'm going to use to calculate instantaneous rates of change. Any questions about how we found the derivative? Okay, so now let's look at the derivative. Where's the only spot the derivative is going to be undefined?
0.
At 0. So we're okay, that's not in our interval either. So we've decided that yes, we believe it has a derivative everywhere from 1/2 to 2. Alright, in order to find the values of c guaranteed by the mean value theorem, I have to take the derivative and set it equal to the what? Average value, or the slope between those 2 points. So here's our derivative. Now we just need the average value. Okay, so that's going to be f of b minus f of a all over b minus a, which is 2 minus 1/2. So f of 2 gives me 3/2. If I substitute 2 into the original, f of 1/2 gives me 3/2 divided by 1/2, which is 3/2 times 2, which is 3, all over what?
2.
2 minus 1/2, which is 3/2. Yes?
Yes.
Okay. So 3/2 minus 3/2 is negative 1.5. So negative 3/2 divided by 3/2 is negative 1. I'm going to pause and make sure that you followed that. Okay, so now that we have the derivative and we have the average value, the mean value theorem says that we should be able to set those equal, solve for x, and there has to be at least one of those x's that's between 1/2 and positive 2. So let's look. Negative 1 over x squared equals negative 1. So if I cross multiply, I get negative 1 equals negative x squared, or x squared equals positive 1. X is plus or minus 1, but only one of these applies to the mean value theorem. Which one? Positive 1. So we say that the c value is positive 1.